Bangalore, India-based robotics lab of Accend Systems Private Limited, which specializes in robots and education, introduced STEMulation Robotics and has already demonstrated it before several thousand teachers at various schools nationwide. Our products and services have received warm appreciation from schools and teachers who have incorporated and implemented our STEM syllabus in their curriculum. This is going to be huge. In current days of global competition, it is important to show students the overall life cycle of a product and bring real-world applicability to what they are learning in school, and so, we are trying to bring to life the abstract concepts of maths and science using robots. The STEMulation Robotics program teaches students how to recognize robotic parts, assemble them, work on the electronics, and program a robot using Scratch. Robots are becoming popular education tools in schools nowadays. They are becoming useful in raising interest of students in the fields of programming, artificial intelligence, and robotics among students across the country. While robots can be an effective and fun way to inspire students to learn about science, mathematics, technology and their applications, they tend to be effective in developing skills to compete the global challenges. Robotics is a great way to introduce and teach STEM principles to the students, but it is not easy to put the correct hardware, software and curriculum together. That's where our STEMulation Robotics Kit become useful. Our STEMulation Robotics Kit is designed as a complete robotic learning experience. The STEMulation Robotics Kit has modular hardware that allow you to build varieties of different pre-designed robots, or you can also design your own custom robot. You can build a robot in no time by combining the versatile and easy-to-program controller, the fully developed Scratch software that allows you to load pre-programmed behaviors easily to your robot and even rewrite and load your own custom behaviors using that software. The simple-to-understand and effective-to-use curriculum guide are just fantastic. That sets our STEMulation Robotics Kit apart from other educational kits. The curriculum guide can be classified in 3 different phases, which include introducing different robots and their features to the students in easy-to-understand analogies, pictures, and examples. This guide helps students to assemble robots and learn the programming part with the help of detailed and step-by-step explanation of the pre-written programming examples. The practical aspect of our curriculum guide provide an opportunity to the students to solve programming problems on their own while learning advanced robotic concepts. Scratch is a visual programming language developed by MIT USA and further enhanced by Berkeley University USA that has been developed keeping the intellect level of students of class 6 to 8 in mind. Scratch enables the student to concentrate on the logical aspect of the programming without worrying about the syntax errors. Also, Scratch complements the hardware and gives the student a platform to give numerous instructions to the robot. Scratch has been developed to help simplify the process of creating and programming animations, games, music, interactive stories and more. The Scratch programming language is primarily targeted at children ages 8 and older, and is designed to teach computational thinking using a simple but powerful building block approach to software development that focuses more on problem solving than on specific advancements to how we approach STEM education and initiatives are on the rise around science, engineering and mathematics. We're seeing a greater impact on how we recognize children's development and understanding of now vital tech skills. Robotics will continue to play an important role. To better understand the role of robotics in STEM education, let's take a step back. According to the MIT Media Lab, coding has become the new literacy, meaning that, in this context, children must learn to design and create digital technology via honed skills such as programming. Hence, schools must more rapidly adopt implementation of STEM-based programs, especially those including programming and coding instruction, particularly as such skills will become more essential than ever before. This is the case due to a specific practical reason: work, and the job market. According to a survey, a good percentage of jobs in the world will become wholly automated within the next 20 years. This will lead to a transformation of labor, and will generate new job opportunities. From our perspective, in the next decade, robotics will become the next computer industry. For instance, robotic use will continue to become standardized, as robots will aid in processes such as manufacturing, security and even household chores. To put it simply, this means that education around robotics, led by STEM initiatives, will be even more prominent, similar to the rise of computer tech in the late 1980s.